So we're in section 10.3. We're going to talk about the unit circle. So there's one piece that we need before we actually talk about the unit circle. We're going to define the angle of rotation. So pretty easy idea. And all the angle of rotation means is how many degrees we're rotating from the positive x-axis. And we're rotating counterclockwise. From the positive x-axis. So if we were to draw a picture, we have our coordinates here. And this is y and x. And we have some angle here. So, and we're rotating some angle counterclockwise from the positive x-axis. So theta is the angle of rotation. But let's look, I'm just going to draw a few examples up here just so we have an idea of what different angles of rotation look like. And I'm not going to label the x's and y's each time. So we could say if we have an angle there, that could be an angle of rotation of, say, 45 degrees. We're just rotating from the x-axis. If we have an angle that goes past the y-axis, then our angle of rotation is just bigger than 90 degrees. So we're rotating around to there. So that would be maybe 120 degrees. Yeah, press.
What does ETW mean?
Counterclockwise. If we go past the y-axis here, we're going further than 180 degrees. So our angle of rotation is bigger than 180 degrees. So if I rotate down to there, so I can't get that straight on the origin. There we go. So we're rotating all the way around to there. And that could be maybe 225 degrees. So I'm rotating all the way around to there. If we go past the negative y-axis, then we're rotating more than 270 degrees. So our angle of rotation just gets bigger. Come down here. That could be possibly 330 degrees. And if I rotate all the way around and past the x-axis again, that just means I'm rotating more than 360 degrees. So if I go all the way back around to there, and I've gone from here all the way around, that could be maybe 405 degrees. So I'm just going more than 360. Or it would say draw an angle of 327 degrees. And you draw it down here somewhere. And then we can also have a negative angle of rotation. Negative angle of rotation just means we're rotating clockwise instead of counterclockwise. So if we were down here, we could say that would be, if we go to rotate this way, that could possibly be negative 45 degrees. And that's the same as going around this way 315 degrees. So negative angle of rotation just means we rotate clockwise instead of counterclockwise. But we end up at the same place if we go around 315 degrees that way, or we go 45 degrees clockwise. We just end up at the same place. The question's on angle of rotation. Pretty easy idea. All right, now we're ready to talk about the unit circle. The unit circle, the reason we call it the unit circle is because it's a circle. Makes sense? With radius of 1 unit. So that's why it's called the unit circle. The radius is 1, whatever our unit is. And the center is at 0, 0. And doing this makes our working with our trig ratios very easy. So let's draw a unit circle here. Here's our circle. Got a center. And we'll draw our x and y axis. And we're going to put a point here on the unit circle. And we'll call that point P. And the coordinates of P, if we're graphing that point, are just x and y. And we've done this a few times, we're going to draw a triangle here. I'm going to go do this, like so, and like so. Well, this is a right triangle. The radius is 1, so my hypotenuse is 1. So if we look at this with and this is our angle of rotation here. We're going up this way, so that's our angle of rotation. And if we label the sides of our triangle, this is the adjacent side, and this is the opposite side. So now we can write our sine and our cosine of our angle. So let's write our sine and our cosine. Sine of theta is the opposite over the hypotenuse. Well, the hypotenuse, because we made the radius 1 unit, is just 1. So that doesn't change anything. And the cosine of the angle is the adjacent over the hypotenuse, which is just 1. So that doesn't change that at all. Well, the opposite side of the triangle tells us how far up we're going from the x-axis. That's our y-coordinate. The adjacent tells us how far over I'm going to get to this point. So that's the x-coordinate of our point. So this is why the unit circle is really convenient to use. So on the unit circle, the x-coordinate of the point is just the cosine of the angle. So the x-coordinate of our point is the cosine of the angle. That's the adjacent side. Because our radius is 1, the cosine of the angle gives us our x-coordinate. And the y-coordinate is the sine of the angle. So all we have to do to find our coordinates is find the cosine of the angle of rotation and the sine of the angle. So working with the unit circle makes our calculation very easy. So any questions about how we've set up the unit circle? We make the radius 1 so that our sine and our cosine are just one or the other sides of our triangles. All right, let's look at a couple of examples of the problems that you might be asked to solve using the unit circle. So on both of these, P is on the unit circle. Folks, electronics, let's put them away, please. We want to find the x and y coordinates. So let's draw a picture. For this particular problem, we have a picture. There's my unit circle. And my angle, here's my point P. And we're going to say that my angle of rotation is 35 degrees. So this is a unit circle. Point P is on the unit circle. We want to find the x and y coordinates. This kind of problem is really easy. X coordinate. It's just the cosine of the angle. The x coordinate of the point is a cosine of 35 degrees, which is about 0.82. The y coordinate is the sine of 35 degrees, which is about 0.57. So our point is 0.82, 0.57. So those are our coordinates. Find the sine of the angle for the y coordinate, the cosine of the angle for the x coordinate. That's all we have to do.
So put in your calculator, you just hit the cosine button and then type in 35. And that's your answer?
Yep, just plug in cosine in your calculator. Cosine of 35 equals, and that's your x coordinate. Sine of 35 equals, and that's your y coordinate. So let's do one more of these. Here is our circle for this one. Move that over a little bit. So this time our point is down here. And our angle is 230 degrees. So before we even calculate, is our x coordinate going to be positive or negative? I'm going to the left here. So is x positive or negative over here? Negative. So we know we have to get a negative. Positive is to the right, negative is to the left. How about the y coordinate? Is it going to be positive or negative? Y is this way. X is this way. So positive up here, negative down here. So y is going to have to be negative. So I know that both of my coordinates are going to have to be negative in this coordinate, in this quadrant, in this part of the xy plane. But we know both of them have to be negative. If they don't come out negative, we've done something wrong. So x coordinate, cosine of 230 degrees. Plug that into my calculator, and I get negative 0.64. That sounds about right. The y coordinate is the sine of 230 degrees. And when I plug that in my calculator, I get negative 0.766. So my point is negative 0.64, negative 0.766. Questions on that one? So when we're finding the x and the y coordinates, we're just finding the sine, the cosine, and the sine of our angle on the unit circle. That's all we have to do. All right. Someone asked about this at the beginning of class, and I said we'd talk about it. So on the unit circle, we can figure out that we have angles that have the same sine or cosine. There are two angles, for any angle there are two angles that have the same sine, and there are two angles that have the exact same cosine. So we're going to talk about why that works out and how we find them. So here's our unit circle. We'll talk about the sine first. We're on the unit circle. So there's my unit circle. And here's my point. We'll call this point P again. And I'm going to draw my radius up to point P. And we'll call this angle of rotation angle A. So we rotated 8 degrees. Well, this side of my triangle is my y coordinate. I'm going to draw another point on the unit circle that has the exact same y coordinate. I'm going to go over here. So here's my other point. We'll call that point Q. And I'm going to draw this one in blue. So we're going to call that angle B degrees. And this side of this triangle is y. Points P and Q both have the same y coordinate. So what that tells us is that sine A equals sine B. The sine of angle A and the sine of angle B are exactly the same because they have the same y coordinate. So for any angle that I pick, I can find another angle that will give me the same y coordinate. So I always end up with two angles that have the same y coordinate. When we use an inverse in our calculator only gives us one. So we have to figure out how we're going to find the other one. We'll talk about that in just a second. So let's make two angles that have the same cosine. So here's my unit circle. And we'll put the center here. Center closer to the actual center. There's my unit circle. And we're going to put a point here on the unit circle again, P. And we'll make our angle. We'll call this angle of rotation again A. Angle A. And now we're going to look at the x-coordinates. We're interested in the cosine. So my x-coordinate is that length. Well, I'm going to draw another point on the unit circle that has the same x-coordinate. Come down here. Here's point Q. I'll draw that angle. And I'll draw the sides of the triangles here in blue. And points P and Q both have the same x-coordinate. So the cosine, and I forgot to draw my angle here. Let's draw the angle of rotation. The angle of rotation for B is, angle B is all the way around there. So cosine A equals cosine B. So those two angles have the exact same cosine. I can always find two angles that have the same cosine. Your calculator only gives you one. So when you find an inverse cosine in your calculator, it's giving you one of these angles. Well, there are two possibilities. We always end up with two possibilities. And there's a nice, easy rule to figure out what the other angle is. So first, questions on why the sines of these two angles are the same, why the cosines of these two angles are the same. Yes? The reason they're the same is we said the sine on the unit circle, the sine of the angle is the y-coordinate. Here's my y-coordinate for angle A. Here's my y-coordinate for angle B. They're both the same. The cosine gives me the x-coordinate, cosine of the angle. The x-coordinate of this point is the same as the x-coordinate of that point, so their cosine is. So to find the second angle that has the same sine, or the second angle that has the same cosine, we have a rule. So two angles. Two angles with the same sine are theta. Our calculator will give us 1. And 180 degrees minus theta. So our calculator will tell us 1 when we do the inverse sine. To find the other, we subtract from 180 degrees. And for the cosine, two angles with the same cosine are theta and 360 degrees minus theta. So our calculator will tell us 1 when we use the inverse cosine. Find the other one, we subtract that angle from 360 degrees. So let's look at a couple of examples of the types of problems that you'd be asked with using this idea. So usually the way they say them, especially in our book, they say the sine of theta is 0.682. We want to find two angles. So the fact that it says two angles is a clue. Between 0 degrees and 180 degrees. So we want to find two values for theta between 0 degrees and 180 degrees. So first off, we're finding an angle. So to find an angle, what do we have to use? Inverse, we have to use an inverse. So we know already that we have to use an inverse. So I'm going to say that that theta is the inverse sine of 0.682. Plug that in my calculator, and it tells me that theta is about 43 degrees. This is just a calculator problem. The other angle is 180 degrees minus 43 degrees, which is 137. And if I check the sine of 137 degrees is 0.682. You plug that in your calculator and check, you'll see that the sine of 137 is 0.682. So the two angles that have a sine of 0.682 are 43 degrees and 137 degrees. Questions on that one? All right, let's look at the cosine. So we have the cosine of our angle is negative 0.891. The problem will ask you find two values for theta. Between 0 and 360 degrees. So we have our angle, we have our ratio, we're looking for the angle, so we know that we have to use an inverse. So theta is the inverse cosine of negative 0.891. Plug that in my calculator. My calculator tells me that that is 153 degrees. Calculator gives me one answer. My other angle is 360 degrees minus 153, which is 207. And we check. The cosine of 207, if you plug that in your calculator, comes out to negative 0.891. But we can always come up with two angles that have the same sine or two angles that have the same cosine. Questions? All right, so our two big ideas from today. On the unit circle, the x-coordinate of our point is the cosine of our angle. The y-coordinate of our point is the sine of the angle. That was our first big idea on the unit circle. Our second big idea is that we always have two values of an angle that have the same sine or the same cosine. And we can find them by using the rules that we just talked about. For sine, one angle comes from our calculator, the other one we subtract from 180. For cosine, one comes from our calculator, and the other one we subtract from 360.